We've got a couple options with this piecewise function problem. We could look at this as 3 separate pieces, or we could look at this as 2 separate pieces. I'll first do it with 3 separate pieces. So we've got piece 1 from negative infinity to 2, piece 2 from 2 to 4, and then piece 3 from 4 to infinity. If we recognize the piece here. Okay, sorry, there was an announcement there. I don't know where I left off. But anyway, we're going to look at this piecewise function as 3 pieces. And in coming up with the equation for the piecewise function, y equals, or f of x equals, there's 3 pieces. So we'll call the first piece from negative infinity, less than x, less than or equal to 2. Or I can just say x is less than or equal to 2. The next piece would go from... Okay, yet another announcement. So this next interval would be from 2, not including 2, to 4, including 4, but then the rest of it would be x is greater than 4. Make sure you don't have an equal to 4 here and an equal to 4 here. All right, could you do less than there and less and greater than or equal to here? Yes. So anyway, the equation of this line here, we can see that the slope is up 2 and over 1. So here the slope is 2. So if the slope is 2 and the y-intercept is negative 4, then we have the piece y equals slope times x plus the y-intercept of negative 4. Then this piece here, this has a slope of down 1 and over 1. So the slope is negative 1. Slope is negative 1. If we were to continue the line, it would go up 1 over 1, up 1 over 1. It would hit 5 on the y-axis. So if it would hit 5 on the y-axis, then extending the line would have a y-intercept of 5. So therefore, we put this piece into the slope-intercept form. Y equals the slope negative 1 times x plus the y-intercept, 5. And then finally we have this line here. This line has a slope of up 1 and over 1 as well. So the slope here is 1. Slope is negative 1, slope is 1, slope is 2. So the slope is 1, and then if it continued with the pattern, down 1, left 1, down 1, left 1, you can continue the pattern, and you would see that this line here would actually go through the y-axis, cross the y-axis at negative 3. So therefore, it would have a y-intercept of negative 3 if it continued. So that's what we need, though. We need the y-intercept, and we need the slope to come up with the slope-intercept form. The slope being 1, y equals slope times x, 1 times x, or just x, plus the y-intercept, which is negative 3. So that's one way you can do it. If you do it the different way, you would do this. The only thing you would change is you would change the interval. Instead of having 3 pieces, we would have just this one piece, which would remain the same. So let's do that. F of x equals 2x minus 4 for x less than or equal to negative 2. And then this is the absolute value function, because that is a slope up 1 over 1, up 1 over on both sides. So it's a v, and the vertex is at 4, 1. So what you should know is that by now is, first of all, this is for x is greater than 2. You should, understanding if the vertex of the absolute value function is 4, 1, it means that h, let me see, where could I put that? H is 4 and k is equal to 1. And so therefore we have y equals the absolute value of x minus h, x minus 4, plus 1. So we would write that right here. So that v right there has an equation, y equals the absolute value of x minus 4 plus 1. Notice that outside of this little, the braces here is the f of x equals, or I could put y equals, but we don't put a y equals inside of here. See, it's just like we have 3 different locations in this first one to go to, so we don't put y inside here. I see that happen from time to time. Students put y in here. That's not what this says. F of x equals, for this this domain restriction, it equals this piece. For this domain restriction, it equals the second piece. This domain restriction equals the third piece. And that's how piecewise functions work. So hopefully that clarifies how to write out the piecewise function that represents the graph below.